This is video 3 on Foundations of Arithmetic, Algebra, and Graphing with a focus on real-life interpretations and applications. I'm Bill Kinney. It's part 3. It's video 3 and part 3. Natural numbers, whole numbers, integers, addition and subtraction, part 3. In future videos, we'll go on to other topics. I've been emphasizing some different kinds of number systems. The natural numbers, the whole numbers, the integers. I've mentioned algebraic properties like closure. You might think that algebraic properties like that are not important, but they are. They are essential for doing math, for understanding it, and for applications. Let me start this video by emphasizing one other algebra property. I've mentioned, actually it was in video 1, that if you take any natural number or whole number or integer and add 0 to it, for example 5 plus 0, you get the original number 5, in this case, back. That means 0 is called the additive identity. It's got the special property that if you take 0 and add it to anything, you get that anything back. No other number has that property. 0 is very special. Related to that, which again I have also mentioned, is that if you take any number and add its negative, for example 5 plus negative 5, you get back 0, the additive identity. Because of this, 5 plus negative 5 is 0, 7 plus negative 7 is 0. I could even say negative 6 plus its additive identity, which is actually 6 itself. Negative 6 means the additive inverse of negative 6 is 6. You get 0. That's the reason why we call negative 5 the additive inverse of positive 5, because when you add these two things together, you get the additive identity 0. Positive 6 is the additive identity of negative 6, because when you add these two things together, you get 0. A couple other terminology things and property things that I want to highlight. They will be definitely helpful as we get toward thinking about algebra. Another thing I want to highlight in this third video is an equation related to this one right here. If you think about your money sitting in a bank, you've got a certain balance on a certain day, maybe it's the beginning of the month, and you want to find your new balance at the end of the month. What you can do is you can take your old balance at the beginning of the month and add your cash flow, assuming that all your money goes into the bank. Okay, so you get money, you're always dealing with your bank, you're making electronic deposits, say, and you're also either writing checks or you've got a debit card or whatever to take money out of the bank. You got your old balance at the beginning of the month, new balance at the end of the month. How do you figure out that new balance? Based on the old balance, you add the cash flow. And the key thing I want to emphasize here, besides this useful equation, is that this equation works whether the cash flow is positive or negative. If the cash flow is positive, you're taking in more money than you pay out, then your old balance, say it was $1,000, plus the positive cash flow is going to be bigger than $1,000. The old balance was $1,000 and your cash flow is positive $200. Your new balance will be $1,200 at the end of the month. But again, the equation works even if your cash flow is negative. If your old balance was $1,000 and your cash flow is negative $200, meaning your expenses were $200 more than your income, based on this equation, 1,000 plus negative 200 is 800. It's the same as 1,000 minus 200. Your new balance is $800 at the end of the month. So this equation is important too. And again, it's always true whether your cash flow is positive or negative. And that's another benefit of having negative numbers. An analogous thing can be said with our motion example. and something that I was talking about in the last video, the second video, I can write an equation that says new position, or new height, in this case, is the same as the old position, the old height, plus the change in position. Change in position. And that's always true too. If your old position was the initial height of 3 feet, and your change in position was 6, right, this 4 plus 2 is supposed to represent the ball initially going up 4 after a certain amount of time, and then continuing up. It had a positive upward speed here to go up 2 more feet. 6 was my change in position. My old position was 3. My change in position was 6. My new position was 9. I was 9 feet high up there after that happened. And then this equation is still true when the ball goes back down, as long as you interpret change in position as being negative. So this next equation down here, 9 plus negative 5, represented an old position of 9, a change in position of negative 4. 9 plus negative 5 is 4 is the new position, and that would be 9 plus negative 5. Okay, no, right here, actually. 4 feet high is where it is after it goes down 5 more feet from being up at 9. All this is leading us also up to thinking about a fundamental thing, especially for graphing, and that's the number line. It's a line, which technically means it goes on forever in both directions. You mark a certain spot, it doesn't matter where, to be where 0 is. You mark a certain amount of length, it could be 1 inch, it could be 1 centimeter, whatever you want, to being to the right of 0, and that will represent the number positive 1. Continue on, typically making these the same distance apart. Technically you don't have to, but usually you do, so maybe you should pretend like I never said that. Make these one distance apart, representing the integers, and they do go on forever and ever in both directions. You can think about the number line as just marking where numbers are in relation to each other. And when a number is to the left of another number, like negative 2 is to the left of positive 3, that means negative 2 is less than positive 3. Written negative 2 less than positive 3. Positive 2 is also less than positive 3. And by the way, these statements should not be confused with this kind of statement. 2 is less than 3, which also means 3 is bigger than 2. Those two things mean the same thing. You can write 3 to the left of 2, but since 3 is bigger than 2, then you put the inequality symbol this direction. Another important thing is interpreting addition and subtraction in the number line. If you start at, say, 1, and you want to add 2, you of course get 3, but that's the same as moving to the right by 2 units. If you subtract 2, that's the same as moving to the left by 2 units. So adding a positive number moves you that many units to the right. Subtracting a positive number moves you that many units to the left. 1 plus 2 is 3, 1 minus 2 is negative 1. What about negative numbers? If I add a negative, like 1 plus negative 2, well, remember, that's the same as subtracting positive 2. So adding a negative, since it's the same as subtracting a positive, is like moving to the left that many units, in this case 2 units. Subtracting a negative, like 1 minus negative 2, is the same in this case as adding the corresponding opposite, adding plus 2. So starting at 1, if you add a negative, you move to the left. If you subtract a negative, you move to the right. Take a moment to think about that. Think deeply about that. That's always what you do. Wherever you start, if you add a positive, you move to the right that many units. If you add a negative, or excuse me, subtract a positive, you move that many units to the left. Correspondingly, by how we know to add and subtract negative numbers, if you add a negative number, that's the same as moving to the left. And if you subtract a negative number, that's the same as moving to the right. And all these are very consistent, and they're all good ideas. And we'll continue to summarize what they mean in other videos.